same size, like a good-looking square should be.
Some good old Sesame Street coming at you. Sesame Street. Hey, which rock band came out with a tip to be square? Do you know that one? We'll give you that one later. All right, so what we're talking about today, we have quadrilaterals. They can either, they fall into three main categories. You either have parallelograms where the opposite sides are parallel, and if it's not a parallelogram, maybe only one pair of opposite sides are parallel, then it's called a trapezoid. We'll talk about those in 5-6. And kites have two pair of congruent sides, but look at it. I mean, they're not opposite each other. Okay, so it doesn't look like a parallelogram. It kind of looks like a diamond, and it looks like a kite. That's why we call it that. But the last couple sections we've talked about parallelograms, and today we're going to talk about special types of parallelograms. You either have parallelograms that have all four sides congruent, or you have parallelograms that have all four angles congruent. Okay, if all the angles are congruent, they have to be right angles, and we call that a rectangle. If all four sides are congruent, then we call it a rhombus. This is like a square that's been tilted a little bit. If you take a square and suppose that a square is not too sturdy and you push it a little bit on top and it kind of bends a little bit, that's what you get with a rhombus, where the angles are not congruent but the sides still are. But if you take the best of both here, you have right angles, you have all four angles congruent, and all four sides congruent, then you'll have a square. Okay, so why don't you pause the video, take a few seconds to draw this graphic organizer here on your notes. Pause the video, draw it down. Okay, so we're back, and if that doesn't work for you, then what we have here is a Venn diagram. Okay, so why don't you pause the video, copy this, then I'll talk about it. Pause the video, copy this down. Okay, so I'm back. What do we have here? All the quadrilaterals. Okay, so kites are a subset of all the quadrilaterals. That means that if you take the quadrilaterals as a whole group, the kites are a small group of quadrilaterals. So all the kites are quadrilaterals. All the trapezoids are quadrilaterals as well. And notice how they don't intersect each other. That means that no kites are also trapezoids, and no trapezoids are also kites. They're different. If you're one, then you're not one of the other. Okay, so we come over here to the green. That represents all the parallelograms, and if you notice, rectangles are completely contained within the parallelograms, and rhombuses are completely contained within, and there's a part that overlaps, okay, and those are called squares. So squares are a subset of rectangles. Every square is a rectangle. Is every rectangle a square? No. Okay, every square is a rhombus. Is every rhombus a square? No. Which rhombuses are squares? Okay, the ones that have congruent angles. Okay, which rectangles are squares? The ones that have congruent sides. Okay, so there's some logic there for you. All of these are parallelograms. So here's a Venn diagram that can help you organize your thoughts about how these relate to each other. Let's go to the next section. All right, so these are the definitions of rhombus, rectangle, and square. Okay, a rhombus is a parallelogram that has four congruent sides. Okay, a rectangle is a parallelogram with four congruent angles, and a square is a parallelogram with four congruent sides and four congruent angles. That's easy enough. All right, so let's look at some theorems about rhombuses. What makes rhombuses special? Okay, what makes them special? We have two theorems here. If a parallelogram is a rhombus, then its diagonals are perpendicular. Okay, so if we look, what does that mean? That means they're perpendicular to each other. Here's one diagonal, AC. Here's the other one. That forms a right angle. Uh-oh. Can you see what's coming up in your future? Maybe some hypotenuse leg proofs. Okay, that's a right triangle. These angles are congruent because this is a right angle here. In fact, that's how I always, when, the old school, before Flip Mastery, you'd have to draw a rhombus on the board. Here's how I draw a rhombus. I would basically make one line, all right, and then make the other one, okay, and then you have to make sure they're right angles, and then you kind of eye it up, okay. So on a chalkboard, I'd kind of like erase some parts, or maybe draw one a little bit longer. So look, all right, so are the diagonals perpendicular? They look pretty perpendicular to me, so this is how I draw a rhombus. I would do that first, and then I would just connect it. Let's look. From here to here, from here to here, big fat red line, and this would draw my rhombus. Okay, that's how I used to do it on the board, so that I knew that the sides would be congruent to each other. The diagonals have to be perpendicular. Okay, so second theorem, if a parallelogram is a rhombus, then the diagonals bisect the opposite angles. All right, so what does that mean? That means that here 3 is congruent to 4. All right, these are bisected, and these are the properties of a parallelogram. Same with 8 and 7. Okay, what about the other side? What about 1 and 2? 1 is congruent to 2, and 5 is congruent to 6. All right, so you can see that, when you look at the diagonals of a rhombus, you have 4 different triangles here, and there are a lot of different proofs that will be set up. They want you to prove different things, and you're going to have to use these theorems here in your proof, because these can tell you if angles are congruent, or if you need two sides congruent, you can use the definition of a rhombus. Or you can just say that the consecutive sides of a rhombus are congruent, or the opposite sides are congruent. So let's do some problems here. Okay, so given that I've just told you these two theorems, what I want you to do is pause the video and fill in 1 through 5. Try to look at the picture and fill in 1 through 5. Pause the video. Go. Okay, we're back. Let's see if you came up with the answers that I came up with. If ABC is a rhombus, then AC is perpendicular to BD. Okay, those are the diagonals. AC bisects angle BAD and BCD. And yes, you can write those different ways and put them in different orders. That's okay. If ABCD is a rhombus, then 1 is congruent to 2. And remember, this is still a parallelogram, so we have alternate interior angles here because the opposite sides are parallel. So 2 would also be congruent to 6, and 1 would be congruent to 5. Okay, so 1 is congruent to 2, 5, and 6. Okay, if it's a rhombus, then BD bisects, okay, angle ADC and ABC, and 3 would be congruent to 4 because that angle is bisected, and 7 and 8, and those are also congruent to each other. How about that? Now let's talk about rectangles. If a parallelogram is a rectangle, then its diagonals are congruent. All right, so this is a parallelogram. Diagonals are the same length. Okay, so now remember, if we draw these, you have to go in order. Let's draw a little picture here. If RSTU is a rectangle, so time out. Let me draw this thing. RSTU, so I can get a good look at it. RS, you can't go down here. You have to go around the rectangle. RSTU. Okay, so RT. So what do we have? RT is congruent to what? RT is the diagonal going this way. That'd be congruent to the diagonal going this way. So RT is congruent to US. US. Ta-da! There you go, done with that. So finding the diagonal length, what they're going to do is give you problems, and they're going to tell you either part of the diagonal or the entire diagonal. Let's see what happens here. All right, underline the correct word to complete the sentence. ln equals 4x minus 17, mo equals 2x plus 13. What are the lengths of the diagonals? All right, so we know that LMNO is a rectangle, all right, because they tell us that right here. The diagonals of this figure are congruent to each other. So if ln, the distance from L to N, equals the distance from M to O, that means that 4x minus 17 would equal 2x plus 13. Okay, so let's solve that here in the box. So 4x minus 17 equals 2x plus 13. How do we solve that? Subtract 2x from each side. We get 2x minus 17 equals 13. Add 17. I'm going to go outside my box. All right. Uh-oh. They cancel. 2x equals 30. We'll do that one in our head. X equals 15. All right, so now remember the question is, what are the lengths of the diagonals? So we're not done yet. You have to plug that back in. So remember, the diagonals are congruent, so we can pick either one. So let's pick ln. So if ln equals 4x minus 17, we're going to plug that value 15 in. And that'll give us 60 minus 17. What is 60 minus 17? That would be 43. Ta-da! So ln equals 43. Done with that problem. How easy is that? That is easy. Okay, so what do we have here? Square ABCD. They tell us AE. Please look at what they're telling you. That's a half diagonal. And they tell us that is 3x plus 5. And BD, that is the entire diagonal. Okay, so what do we know? We know that BD is 2 times AE. So I'm going to write that out. BD equals twice AE, which in this problem means that 10x, ooh, man, was that ugly, 10x plus 2 is equal to 2 times whatever AE is. So that's 3x plus 5. All right, now what? Let's just do a little algebra. 6x plus 10 distribute. Let's subtract 6x from each side. Goodness gracious. 4x plus 2 equals 10. Subtract 2 from each side. 4x will equal 8, and then x will equal 2. But what do they ask for? The length of AC. AC is the entire diagonal. It's the same as BD. Well, we know BD. Here, how are we going to write this out? So AC is the same as BD, which is the same as 10x plus 2, because that's what they told us. And we know that x is 2, so this equals 10 times 2 plus 2, and that all equals 22. So AC is going to equal 22. Ta-da! There's that one for you. Okay, so I'm pulling up your practice right now so we can look at it together before you have to start it. Okay, decide whether parallelogram is a rhombus, rectangle, or square. Okay, so that's based off of these markings here. Can you tell which one it is? We went through the theorems, so you just have to use the theorems and look at the picture, and you want to be as specific as possible. In other words, like some of them might be squares. Okay, they're also rectangles and rhombuses, but you would write down square because everybody knows that a square is also a rectangle and a rhombus. All right, and for questions 5 through, what do we got, 10 here, you have to figure out, this is based off the fact that the diagonals bisect each other, so that means that 38 degrees is this angle, it's also this angle here, and remember that each one of these is a rhombus. All right, so the opposite sides are parallel, so you can start looking for alternate interior angles. So that's how you solve a lot of these. Don't forget that the diagonals are perpendicular to each other. And you have to draw the rectangle like we did there. Find that one. All right, what else we have? Find the most precise name. That's like above. And 16 and 17, assume these are rhombuses. It doesn't say that. These are rhombuses. Okay, so what do you know about rhombuses? And then you have to figure out some logic here. All right, so that's it. That is section 5.4. We're going to leave you with some Huey Lewis in the news. That is the answer to the trivia question. This is Mr. Kelly Baumholder. Remember, it's nice to be important. It's more important to be nice. So